All right, part 2. We're starting with number 6, so this will be number 6 through 10 of your physics worksheet for your vector test review. On number 6, it said, if Joe rides south on his bicycle in a straight line for 25 minutes with an average speed of 16.5 kilometers per hour, how far has he ridden? Well, roughly, straight line, 25 minutes, so we know time equals 25 minutes. And then we also were told a speed or average velocity of 16.5 kilometers per hour. If that's the case, we want to solve for distance. Our problem comes into play that these hours and these minutes are not the same. So we're going to have to convert one or the other. To me, it's easier to convert the minutes into hours. So for 60 minutes, I have 1 hour. So that will, when I do that math, that's 0.42 hours. So now I'm going to solve for d. I'm going to use the original equation, v equals d over t, or d equals vt. Whichever way you want to write it would give you credit. You do need to get back in the habit of doing these variables, formulas, work, answer, and unit for these problems for you to get full credit on this next test, all right? t equals our v, which is 16.5 kilometers per hour, times our 0.42 hours. So then we cancel out our hours, we multiply, and we find out that we're able to go a distance of 6.93 kilometers, and I should include south since I was given that information, and this is a vector value really, even though it talks about average speed, since it gives us a specific direction in saying south, go ahead and say that he continued south. The next one, number 7, Stephanie hits a volleyball from a height of, so that's our distance. We have a distance of 0.55 meters and gives it an initial velocity of VO of a 6.5 meters per second straight up. So I'm going to go ahead and do that to tell me it's up. I want to know how high will the volleyball go. Okay. Well, something to realize is that, okay, here's our little Stephanie. All right. This right here, okay, as she jumps up and hits the ball, she's already at 0.55 meters. Okay, and then she's going to jump up and spike that ball. Okay, that volleyball. Now, as she spikes the volleyball, it is going to go up into the air. Okay, so it's going to go like that. The thought process here is gravity is involved because we're talking about the up down and how high it will go. When we're talking about how high it will go, we're talking about this directional information. So we're going to go ahead and pull gravity in here. Because it's going up, we'll use a negative 10 meters per second squared. Also, at the very top, when the volleyball starts coming down, its speed will be 0 meters per second. These are a few things that you need to remember when you're doing this type of problem. Now, this particular distance right here will need to be added at the end. Because we're really just going to find this distance right here. All right. So we're going to find D. To find our actual answer, our how high our total distance, we'll do our D1 and our D2. We'll add those together. So to find D2 though, we're going to need to use the formula that has gravity in it. And we have, with no time, we have to look for a formula that has no time but has gravity because we're going to be using those variables right there. So we're going to use our VF squared minus VO squared divided by 2G. Now, I wrote that, but really the original formula is VF squared equals VO squared plus 2DG. And I just solved for D. okay, by manipulating the equation. So I'm going to plug in what I know, 0 squared minus my 6.5 squared divided by 2 times my negative 10. And when I do that, I get a distance of 2.11 meters. But I have to add the 0.55 meters in, and so it gets a total height of 2.66 meters. All right. So the thing to realize is I have to first find the regular distance. I have to find this D2 here, and I'm given D1. I'm actually trying to solve for the total D. Okay, so I want DT. Then how long will it take the ball to reach its maximum height? How long is actually time. So I'm also going to solve for time. The thing to realize is I'm going to end up doing, I have to pick something with a formula that has time and gravity in it. Since I have a change in speed and I have a gravity, I'm going to go ahead and use the formula T equals VF minus VO over G or A. That's the basic acceleration formula manipulated. So I'm going to have 0 minus my 6.5 divided by a negative 10. And so 6.5, negative 6.5 divided by negative 10 is going to give me a 0.65 seconds. Now there are several different ways you could have done this problem to have solved for time, but this is probably one of the easier ones because you do have to have gravity involved in the formula still. Okay, so moving on. Number 8 is where we really get into where we're talking about vectors, because up until this point it's been primarily a review of motion and trig and things like that. So number 8 says that a football is launched at an angle of 29 degrees to the horizontal at a 30 meters per second. Now this information in this first line, because it has an angle and a magnitude, it's literally your resultant already. So it's going to be what you draw here. So it's an angle of 29 degrees to the horizontal, and it is 30 meters per second that we have launched this football. We are asked to find the horizontal and vertical components. So really all we're finding are x and y. So I need to make this into a right triangle so that I can determine, because this football is going to need to go forward and up if it gets launched at this angle, because obviously the football player is passing it to someone and they're going to be a little bit further away from them. So I have my x, wrong color, let me fix that. I have my x and I have my y. So really all we're doing is we're going back to trig and we're understanding that our vectors have to be created, and then we're using our trig to go ahead and solve for those. So to solve for x, I'm going to use cosine because that's the adjacent side of the triangle of 29 degrees equals the adjacent x over the hypotenuse, which is 30 meters per second. I'm then just going to cross multiply and solve for x, where x will be 26.24 meters per second, and I'm going to say forward. Now, could you say horizontally or across? Yes, any of those would work. Then for the y, since that's the opposite side, I'm going to use sine of 29 degrees equals y over 30 meters per second. Again, I'm going to cross multiply. So y will end up being 14.54 meters per second, and this will be up or vertically, either one you could say. All right. Those are pretty easy. They should remind you of the warm-up that we saw in class, unless you're 5th or 6th period and then y'all didn't get to see that warm-up. Okay. So again, we're just looking for components, which is sides. Moving on. A girl delivering newspapers travels 3 blocks west, 8 blocks north, 6 blocks east. What is her resultant displacement? All right, we can do this a lot of different ways. If I told you that you had to solve it graphically, then what you would do is you'd have to have a ruler and a protractor, and you'd write a scale. And that scale, let's just say, I'd say is 1 centimeter equals 1 block. Okay, so I'd start off with my 3 blocks west. Okay, well, 3 blocks west, I'd draw a 3 centimeter long line, and I'm not measuring these out, so they're not perfect, but I'm just kind of giving you the idea. 3 centimeter long line, and I'd label it 3 blocks. I put my arrow to say that it's west. Then I would turn and I would go up 8 centimeters, and I'm going to draw all the way through my little lines here to give more of a realistic. So that would be 8 centimeters, and I'd label it 8 blocks. And then we're going to turn and go 6 blocks east. So I'm going to turn and I'm going to go east about twice as long. Ooh, that doesn't look right at all. Okay. Yeah, we'll go with that. That's good. All right. And then we would say that that is 6 blocks, and it would actually be measured out to be 6 centimeters long. Then what I would want you to do for my resultant displacement is you would literally come over here with your ruler. You'd go from beginning up here at the 3 blocks to up here at the 6 centimeters, and you would lay the ruler down and measure it. Okay, that would be one way that this could be done. You might find that it's close to 8 or 9 blocks, somewhere around there. Another way, you'd also need to find an angle, and you could either find, I'd probably find this angle right here, okay, just because, and so I'd lay my protractor down so that the 0 would be here, and I'd measure upwards. And then that angle measurement, let's just say it's somewhere around, I don't know, 70 degrees, and then I would say that it is, let's say that it would be opposite of adjacent. So my opposite direction is north of east. Okay. So this would be, the answer. Let's say it's like 9 blocks. And remember, I would always give you a range. Okay. If I didn't say you had to do it graphically, though, most of you would solve it mathematically. And mathematically, you need to remember that anything north is a positive x, anything south is a negative, positive y, south is a negative y. You can tell it's been a long day already. All right, x is going to be east and west, and east is going to be a positive x, and west is going to be a negative x. So let's go back to what we know. For our x's, did we go east and west? Yes, we went west right here, 3 blocks, so that's going to be a negative 3. Plus, we also went east 6 blocks, so that's going to be a positive 6. And so that's going to be 3 blocks. Since it's positive, that means it was going east. Okay. Then for my y, we only went one direction. We just went 8 north. So that's 8 blocks. It's positive, so we'll go upwards. So now we're going to create another triangle where we go 8, and then we go over 3. And so we have 8 blocks and 3 blocks. And then we're going to go ahead and draw our resultant. So we could find this resultant by doing Pythagorean theorem. And we would do 8 squared plus 3 squared square root and solve for r. We could solve that it is 8.54 blocks. Now for the angle, we would do the inverse tangent of opposite, which is our 3, over our adjacent, which is 8. And when we do that, we get that it's a 20.56 degree angle, but now our direction would be different because our opposite side is east and our adjacent side is north. So this would be east of north. Okay, so a lot of it would depend on how you did it and how you drew your angle and some things like that. But again, you could do it both ways. Either way would work. So these answer A, because again, they wanted to know resultant displacement. Resultant has to have a magnitude and direction. Displacement, again, is just from beginning to end, how much did you do? Now, the total distance that she traveled, which is part B, is adding all of it up. How many steps did she take? That's the difference between displacement and distance. So total distance that she took, well, she walked 3, and then she walked 8, and then she walked 6. So her total distance was 17 blocks. So that is one of the differences. Also, a distance is a scalar value, so there's no reason to have directional information on this. All right. Number 10. Number 10, we have information given to us that we travel 56.8 meters at an angle of 30 above the horizontal. Okay, again, if I give you a measurement, a magnitude with an angle, I'm giving you the resultant. So I'm giving you this angle right here of 30 degrees and 56.8 meters. I'm then asked to solve for how far does it move horizontally and vertically. So again, I'm really just looking for x and y. To do that, we would have that x is our cosine of 30 degrees times our 56.8 meters. And then when we multiply that out, we get 49.19 meters. And I could say across or forward, either way, but I have to have some direction as well as magnitude. And then y is going to be my sine of 30 because it's the opposite times my hypotenuse, which is 56.8 meters. And that's going to give me an answer of 28.4 meters, and this is up because the roller coaster is rising. So this would be pretty much things you need to know. I would also suggest going back over some of those problems that we've worked or the information that I have given you. I've scanned my trig problem answers in so you guys can look at how I worked those problems as well. So hopefully you guys have enough to look at with your graphical and mathematical worksheets as well as your trig worksheet as well as these reviews. Hope you do great on your test. See you Thursday and Friday for that. Remember, bops are on the web. If you're already here, print them off and try them. Check you later.